Welcome to part 2. Before going further, I should take a minute or two to focus on the definition of the leading and trailing edge, just so that we are on the same page. Identifying the leading and trailing edge will be important to later separate the F1 into having the upper surface as well as the lower surface. This will not only assist in designing the guide curves, but also in post-processing, where we may need to extract the CP and CF values for either surface. I guess many of us are under the impression that the leading edge is the frontmost point on the airfoil. This is quite misleading because, for example, if you take this airfoil over here, let me just take a quick snip. The frontmost point on this airfoil is actually here, but the location of minimum radius is here. Therefore, this is the leading edge. The leading edge is the point at the front of the airfoil that has a maximum curvature, in bracket, minimum radius, based on this reference over here. Okay, now we are done with that. Let's jump right into it. The first step will be to choose an airfoil with a closed trailing edge. In today's example, I have selected Professor Slick's S1223 airfoil, since I find its concavity on the lower surface to be much more challenging to mesh compared to other symmetrical or convex airfoils. Let's start. Okay, let's just import the coordinates, text file. I guess we already know how to convert the coordinates. Spacebar, front plane. Just convert entities and scale it up. I've chosen 100 and okay. Exit the sketch. Just rename it. Okay, I'm going to hide the curve. Convert entities again. And now I'm just going to cut off the trailing edge. This is since I'm going to use offset entities later on, and I will have problems if I don't just trim it off. From the origin to the center point. And let's see 99.5. Just a guess, it's okay. Just trim it off. There you go. Maybe just change this one into construction line. Exit the sketch. To make things neat, I'll just do different geometries at different sketches, just so that you can follow better. Front plane again, convert entities. And now you can try to offset the entity. We'll go for 2. This is for the first shell. Maybe you can go with 10 for the second shell. What about 30 for the third? And maybe let's try 70 for the fourth. Okay, exit the sketch. Just rename this as shells. Okay, front plane again. Now let's introduce a region for the wake so that the mesh can be relaxed. So we'll start from the trailing edge. So this is 100. And I'm going to set the length for the mesh to relax, just another chord length. So it's just 100 again. Okay. Make it a bit taller. Okay, exit the sketch. Can just rename this as vertical lines. In the sketch, just convert entities for the fourth shell, as well as the first vertical line. Now just extend entity and just trim it off for the top part. Now we are just gonna approximate a line which is let's say midpoint, midway, just so that we can estimate the guide curves later on after this. Just extend it a bit. Okay. Now we'll do our first guide curve. I like to use the star spline. It's easier to control. And another one from the bottom. Okay, we'll make both of this collinear as well as perpendicular to the line earlier. Okay. Now we can easily adjust the control. Okay. Just make sure that this part over here is actually vertical. Okay. Just now I just snip it to this vertical line so that it's automatically vertical. Okay, let's move on. Exit the sketch. Or maybe you can just do this first. Yeah. Just convert the newly designed guide curves as well as the second vertical line. Just rename it as vertical line 2. Okay. Now it looks less messy. I can turn on the shelves. Okay. From plane, convert entities. Now I want to extend the shell so that it intersects with the guide curve. Just remove the excess. Be careful with the ones like this. It's very close. You may miss it. So just extend this. Yeah. Okay. Now we can start doing our domain. Let's start from the trailing edge. Okay. like a rectangle. Well, we're gonna make it a square. Start from semicircle. Since we are doing a C-shaped topology, make both of this equal. It will be 20 chord length on top and bottom, so it will be 40 chord length. 40 times 100, 4,000. Okay, I'll just trim it off. Oops. Okay. I'll just delete this one. There you go. Now I want to draw a straight horizontal line that will extend all the way to the what do you call this, outlet. But I'm just going to do it like this, and then we'll extend it afterwards. Okay, just extend, just like so. Okay. Then I'm just going to draw a straight line, straight vertical line. This will be the limit after the wake, that the mesh will be defined into being a straight rectangle. And that's the limit over there. One chord length after the trailing edge. Then just trim it off. Okay. Now just another front plane sketch. We'll connect to the corresponding shell to the horizontal line. Just make sure that both of the on the right it is horizontal, and on the left it is tangent to the curve. You're just guiding the mesh to be relaxed into becoming a straightly a rectangle. Yeah, make it tangent. You can control the points. Okay, starting off from the trailing edge, horizontal, and then this one can be perpendicular to the guide curve. It's the same thing because we have designed the estimated line just now near the trailing edge, right? So just continue doing it for the third shell. Horizontal, tangent. Same thing on the top part. Tangent. Okay. Again for the second shell. Horizontal, tangent. Just move it to make it look smoother. And the last shell shell 1, tangent. Just move it up. Just approximate so that the gaps are almost equal in thickness. Plus 1. Horizontal and tangent again. Just move it up. Try to guess. So they have almost equal thickness. It doesn't need to be perfect, but just eyeball it. That seems okay. That's another sketch. Just convert the first shell so that I can just isolate them. Rename it. Shell 1. Height. Do the same thing for the remaining shells. Shell 2. Height. Shell 3. One more time for shell 4. Okay. I guess we need to do for shell 0. Just after the trailing edge. Yeah, this one's. Okay. I'm just gonna do for the vertical lines. Vertical line 3. Okay. Now I can hide the messy sketch earlier and use this instead. Okay, now I'm gonna try to find the minimum radius. Also the lineation. Now this is quick trick. Here you can just select the spline, right click, and SolidWorks will give you the minimum radius over here. So just select that. The reason why I needed to trim this part is that if I don't, then the minimum radius will be located at the trailing edge. So we know where the trailing edge is, so it doesn't matter. So that's why I trim this off, so that this will be, the minimum radius will be on this part, on the front part. Okay. So this will be your leading edge. Just eyeball it. That's good enough. Now I can just delete this. I'm just going to convert this for the, yeah, that one. This one is just to assist me in trimming the airfoil into having the upper and lower surface. So leading and trailing edge lines. Okay. Just hide those. Front plane, convert empties, select the airfoil, as well as the two lines. Now I can just trim the lower surface and have the only the upper surface. Okay. Now I'm gonna draw dots on the airfoil on the upper surface and maybe say 20. The reason being is that if the airfoil has a very strong curvature, then I will need more dots over here so that I can draw the normal lines. If the airfoil is quite flat, then you don't need lots of points. Okay, this is just an estimate of 20. You can do more, you can do less, it's up to you. Oops, just remove connections. Okay. You can just hide that one. Do the same thing on the lower surface. Convert the airfoil as well as the lines. Oops. Okay. Trim the top part off as well as the lines. There you go. Now you have the lower surface. Segment, whatever you did for the top part, you do the same thing for the lower surface. Now both of them have 20 dots, and that's it. Okay. Now I can just hide the baseline and use the upper and lower surface sketch instead. Okay. Now, near the leading edge, it is not actually enough to have only one normal line here and another over here. So I'm planning to add more normal lines over here, maybe about 8, 10. Let's see. Convert entities. Okay. Just intersect with the first shell. Yeah. So this is so in this part I'm just gonna draw all the normal lines first. Just gonna fast forward, not to waste your time. Just make sure they are perpendicular to the airfoil. You can just hover it and then you will properly snip into place. Okay, now near the leading edge, and just trim the excess surface. Okay, the same strategy. Segment, maybe 8. It seems okay. Do the same thing on the low surface. Okay. Now, same thing. Just make sure it is perpendicular. Repeat it for all the dots. Oops, yeah. Okay, we are done with that. Rename it. Normal lines 2. Okay, I'm just gonna convert everything into one sketch just to make it neat. And we'll help later for the split lines. You'll see. Okay. Just rename it as normal lines 3. Just hide the first two sketches. Now just to convert the semicircle. Now we are planning to do the guide curves. Then just take one line over there, and then you can use circular sketch pattern, just like the vertical line as your entities to pattern, and select the center of your circle, which is at the joining edge. Okay. Now it is 360. I don't want that. I just only want half of it, 180. And since we did 20 points on the top part of the F wall and 20 on the bottom, so we have one at the lineage, so we can have 41 lines like this. The reason why I did this is because, let's say when I want to draw the guide curves, I know that it is always normal to this semicircle. Okay. Just to check whether that one is the center part, yeah, because it is horizontal. So again, using a styled spine, connect to the leading edge. Just make both of them linear. And this one can be horizontal since it's at the center. Can control and adjust. And then the star line. You can just approximate as you wish, but I'm going to do two on each, three on each side. This one is a mistake. Okay, you don't have to follow this one. I'm going to remove this one afterwards. You draw another star spine. starting from the first shell. Oh, sorry. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Yeah. Okay. Sorry for that. Linear. And make this one and this one to be linear as well. And we're going to repeat the process. 1, 2, 3, 4, 5. One, two, three, 4, 5. Okay, that one, the normal line, we linear with this one. This one and this one to be linear again. Yeah, we can just, I'm going to adjust the control vertex afterwards. So now just going to add more star splines. Usually I just use 2 control vertex, and that should be sufficient. Select the normal line. Okay. Linear. Then you can adjust. Another one for the top part. Normal line. Linear with this one. And this one linear with the outer part. Okay. Need to adjust this one as well. You actually just need to imagine, example, you have one compartment here, another compartment here, one compartment here, another, so on and so forth. Just estimates that they are almost similar in size, something like this. One, two, three, 4, 5, 6, 7. I think it's going to be 8. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Again, same thing, linear. One, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Readjust. This one you can just make a straight vertical line all the way down. Same thing on the top. Okay. Readjust as you wish. Again, remember about the compartments. Doesn't need to be perfect, but at least you can just eyeball it. Now I can just convert empties for the guide curves. Okay. Then we can hide the main sketch for the guide curves. Okay, now it looks better. Guide curves. Maybe you can just readjust this one. Okay, now we can make a planar surface for the main domain. Okay, so features, planar surface. Okay. Now the idea is that we want to transfer all these curves into ICM. The way that we can do it is by splitting the main surface into small surfaces. And that's what we're going to do. We can do this by selecting split line. Okay, focus here is projection. Now, first we can select on the sketch. Later, on this part here, you can just select the surface. I'm selecting the guide curves. Okay. Split line again. Can use the drop down menu over there. I can select shell 4 first, maybe. Okay, shell 0. All right, you can just repeat it for the remaining shells. Shell 1, shell 4. Split line again. Shell tree. You have to select its faces where you wish to split. And just repeat the procedure. Shell 2. For shell 1. Okay. Now I can do for the normal lines. This is why I like to name my sketches so that it's easy for me to find them. Okay, there you go. And looks like our guide goes are missing. At times it's like that. I'm not really sure why, but you can just repeat it, and supposedly it should be okay. You have to select all the faces that you have splitted earlier up to that point. Yeah. So let's these two. Okay. We are done.